commonly used density curve we have is the normal distribution curve. And the normal distribution curve is completely defined by two numbers. The idealized mean, which is given by mu, and the idealized standard deviation, which is denoted by sigma. This curve is symmetric, it has a single peak, and it is bell-shaped. The mean number, mu, determines where the curve lies along the x-axis, and the standard deviation, sigma, determines its height. I can see two normal distribution curves here. This left curve has a standard deviation of 1, while the right curve has a standard deviation of 0.5. In general, smaller standard deviations means this graph is going to be much thinner and taller, and larger standard deviations makes it a little more wider and flatter. It is harder to find the area under this type of curve than the uniform distribution. However, there are some general rules we can follow. We're going to look at what is known as the empirical rule, and this gives some estimates for proportions lying in particular ranges. The first part of the empirical rule states that approximately 68% of our data is contained within sigma of mu. This means if I start with the mean and I go both up and down by a single standard deviation, that range is going to hold about 68% of my data. It also says approximately 95% of data is contained within 2 standard deviations of the mean, and approximately 99.7% of the data is contained within 3 standard deviations of the mean. This diagram shows this idea of this empirical rule. We can see that on the x-axis we have mu at the center, that's the mean. We add standard deviations moving to the right and subtract them moving to the left. Between mu minus sigma and mu plus sigma, that's 64%. If I go up and down by 2 standard deviations, that's 95%, and up and down by 3 standard deviations is 99.7%. When presented with a normal distribution problem, our first step is going to be to draw this curve and fill in the values on the x-axis. We are then going to shade the appropriate region using the empirical rule and the symmetry of the curve to define our final proportion. So let's look at an example. The upper arm length of females over 20 years old in the US are approximately normal and have a mean of 35.8 centimeters and standard deviation of 2.1 centimeters. Before we get into this problem, my first step is going to be to draw and label my curve. Here, I have an approximation of a normal curve, and at the center is going to be my mean, 35.8. I'm then going to add 2.1 to get my next tick mark. 35.8 plus 2.1 is 37.9. Adding 2.1 again gives me to 40, and then one more time gets me to 42.1. To go to the left, I'm going to subtract 2.1. 35.8 minus 2.1 is 33.7. Subtracting 2.1 again gives me 31.6. And finally, 31.6 minus 2.1 is 29.5. So now I have my curve drawn and labeled. Let's suppose I want to know what range of lengths covers 95% of this distribution. And our empirical rule told us that that was 2 up and 2 down. So I'm going to move up by 2 and down by 2. This is the region I'm concerned with. And I can see those marks on the x-axis as 31.6 to 40. So 95% of females over 20 years old in the US will have upper arm lengths between 31.6 centimeters and 40 centimeters. Next, let's look at what percentage of women over 20 have upper arm lengths above 37.9. For this, I'm going to go ahead and draw this line at 37.9, and above is going to be to the right. Those are the bigger numbers, so I'm going to shade that region here. So in order to figure this out, I'm going to have to do a little bit of side work. because this was not specifically given to me in my range. However, between 33.7 and 37.9 does hold 68% of my data. We do know that. In addition, halfway is going to hold 50% of my data, so there's going to be 50% to the left and 50% to the right. Splitting that 68 in half tells me that between 33.7 and 35.8 actually holds 34%, and between 35.8 and 37.9 holds 34%. So now I see that 50% is going to be above 35.8, and if I remove the 34% that's between 35.8 and 37.9, the piece that I don't want, I'm going to end up with 16%. So 16% of women will have an upper arm length above 37.9 centimeters.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.